Okay, Assalamualaikum and good afternoon. Question that I picked up from past year, December 2018. So you can check it out. The 7 meter long internal column. So this is the L. Not effective length, L saja length. Internal column in a rigid jointed steel structure is required to support ultimate design load of 1,600. So here dia dah bagi 1,600 as the total load. So you don't need to calculate untuk dapatkan dia punya 1.4 GK plus 1.6 GK sebab dia tak ada bagi dead load imposed. So dia dah bagi total ultimate design load. Maksudnya dah kira ultimate load 1,600. As shown in figure 5, assuming the fixity at the top and bottom of the column are restrained in position at both ends but not restrained in direction. So this one we'll look at later when we're going to calculate for effective length. Baru kita tengok this one. Show whether the section 254, 254, 167 UC is adequate. And this question also give you section to check. You don't need to suggest any section ataupun try any section. Tak perlu nak pick up like random section daripada table. Just use this section for the sake of to complete this question. Kita kira loading, but since loading given dah ada dalam soalan, kita tak perlu kira lagi lah. We can just tulis je ultimate load ataupun axial load is equal to 1,600 kilonewton. So that is the load. What we do next is kita dapatkan dia punya LE. Macam mana nak cari LE, which is the effective length, which is the formula. Bukan formula, dia punya factor. Factor dia kita tak tahu berapa. So factor ni depends on the end fixity of the column. Fixity, kena tengok on the question again. Assuming that fixity at the top and bottom of column are restrained in position, means that atas bawah kolom awak restrained in position but not restrained in direction. Okay, atas dengan bawah juga not restrained in direction. Okay, restrained in position saja but not restrained in direction. So we have to look at the table. Nominal effective length LE for a strike table. Effectively held in position at both ends. So means that kalau you tengok dekat sini, possibility keadaan dia, the condition itself is brace column. Brace 1, 2, 3, 4 ni. Condition 1 sampai 4. Okay, is a brace column sebab it is effectively held in position at both ends. Kalau you tengok dekat unbrace, okay, kat unbrace, effectively held in position and restrained in direction at one end. Okay, so one end dia memang direction position dia okay, which is good lah. Tapi at the other end not held in position at all. So maksudnya tak fulfill the fixity in the question. Sebab satu lagi not held in position. Okay, position dia tak held. Sebab sekarang kita nak top and bottom dua-dua held in position. Possibility-nya hanyalah brace saja, unbrace tak adalah. Yang 5, 6, 7 ni not, no, it cannot be. Okay, and then another thing that we need to look at direction. Okay, it says that not restrained in direction, both and not restrained in direction. Okay, so the first one is restrained in direction at both ends. So tak betul lah sebab this one restrained direction. Partially restrained direction, tak betul juga partially restrained. Restrained in direction at one end, tak betul juga sebab dia dua-dua side, dua-dua atas bawah tak restrained in direction. Last kali not restrained in direction at either end. So this is the one. Sebab dua-dua atas bawah not restrained in direction. So that is 1.0 L. So we pick the number like the factor is 1.0 L. Okay, and then 1.0 times the length, which is 7 meter, given the question, kita dapat 7 meter lah. So that is on the effective length. Dalam soalan dia dah bagi suggestion to use 254 times 167 UC. Kalau soalan bagi pakai dalam soalan, jangan gatal pergi saja section baru. Bila awak saja section baru tak ada markah. Okay, tak kisahlah if let's say the section is not suitable at all, doesn't matter. Sebab dia suruh pakai section tu. So you check, tak okay lah, tak dia lah. Kira sampai habis. Dia dah bagi section ni, so when kita nak dapatkan berapa PY, we know that the first thing that kita kena tengok adalah P, which is the thickness. Thickness of this section, 254, 254, 167. So we have this table. This is 254, 254, 167. Look at the value of P, 31.7. What we need to do, so kita nak tengok, because kita nak check PY, so kita kena tengok dekat table yang ni lah. Design strength PY for grade 43 steel. So since it is 31.7, so ini kosong sampai 16, 17 sampai 40. So dia in between the 17 up until 40, it is PY equal to 265. Since they're more than 16 mm but less than 40 mm. Okay, PY will be 265. And then we need to classify the section classification. We need to find the value as usual, B over T and D over, kita kena tengok B over T and D over T berapa value dia. Section classification maksudnya kita kena tengok dekat UC table again, table of properties of 4.17 and 10.4. B over T is 4.17 for flange and for web is 10.4. Kita kena compare lah, compare dengan table ini. Table ini as usual nampak ada constant, jadi kita kira constant ni dulu. Constant equal to, you know, the formula is 275 divided by PY square root. Just simply write, you know, the PY is 265. And square root this value, we're going to get some values lah, which is I dapat 1.019. 1.019. So, yang mana satu kita nak tengok dekat limiting width to thickness ratio. This one, this table 2. We know that column adalah compression punya elements, okay? Elements of structural elements yang resist compression. Apa-apa yang related to compression akan masuk pada column. So, you see this is compression and this is compression. Tengah ni tak ada. Actually, B over T ni, you akan pakai for both column and beam. Yang B over T ni lah. But D over T yang kat sini adalah untuk beam. So, this one for column. Kalau you baca pun web where the whole section is subject to compression. For roll section. Actually, dia punya table ni sebenarnya banyak lagi. You know, you have like lots of other types. Sebab dia ada roll section, dia ada welded section. Different types. But this one is like the one yang being extracted and simplified for the use of learning. Okay, 9 darab constant probably is 9 point something lah. Sebab 9 darab 1.019 tadi is around 9 point something. And 40 times 1.019 become 40 point something. But when we compare dengan our B over T for 9 constant, obviously our B over T is only 4.17, which is less point daripada 9 point something kan. And D over T pun obviously is only 10.4, which is less than 40 point something lah. Doesn't matter as long as dia plastic compact ataupun semi compact, it is okay for column. Okay, yang kita tak nak dia slender. Why? Because slender, when you calculate for compressive resistance, which is the PC equal to AGPC yang sebelum ni I ada dalam example sebelum, example 1 yesterday, dia pakai formula lain. Okay, so for slender, formula dia different and formula dia lebih complex. 9 constant and it's also less than 40 constant. 9 constant is 40 constant is 40.76. Okay, darab je dengan this 1.019 constant. Therefore, section is not slender. Kita dah done with the section classification. Kita nak kira dia punya PC. PC ada 2 PC. Nama dia PC juga. Satu PC macam ni, another one is PC besar. Okay, PC yang kecil ni, PC sengit ni, that one is compressive strength. But PC besar ni adalah compression resistant. So kita kena cari compressive strength. So to find the compressive strength, we need to do it arah XX and also arah YY. I like to do it serentak lah. So that kita boleh refer table, tak perlu back and forth, refer table sekali dan terus tulis. So for XX, kita kena dapatkan dia punya RX. Okay, and Ry, which is the radius of gyration. Because you know the formula for slenderness ratio, because you trying to find the slenderness ratio, LE divide by Rx. X ni maksudnya arah X lah. And slenderness ratio LE divide by Ry. We can find the radius of gyration by referring to the properties of section for UC. Universal quantum. So kita tengok radius of gyration. So here you have the radius of gyration. Radius of gyration for X is 11.9 and radius of gyration for YY is 6.79. Noted juga dia dalam sentimeter. So dalam table tu the units is in centimeter. Okay, so 11.9 this is in centimeter. And for Ry is 6.79 also in centimeter. So when we calculate to slenderness ratio, it's better if we convert it into millimeter. Darab saja 10. So this one becomes 67. And then we can find the slenderness ratio by dividing the effective length with the radius of gyration. For the effective length, tadi kira dekat atas ni, it is 7 meter. 7 meter, this is in meter, tukar into millimeter, become 7,000. Divide with 119 mm. So dia akan hilang. So you akan dapat tak ada unit, the unitless slenderness ratio. Nama dia pun ratio. So obviously ratio takkan ada unit. Do it for the same thing for Haziq and Sean. Are you around? Haziq for XX, Sean for YY. 58.824. Okay, betul. Thank you Haziq. 103.092. Ke 093 kah? So 103.093 Thank you Sean. You kena cari PC. Maksud saya PC tu is compressive strength. You need to find the compressive strength. So you need to know which table you're going to refer. You have curve A, curve B, curve C, curve D. Banyak table. Tengok dulu table ini. So we have curve A, curve B, curve C, curve D. Okay. So which table you're going to use? Okay. Ignore whatever above here because kita tak pakai roll I section. Okay, roll H section hot roll structural hollow section ni yang kalau macam ni lah hollow section. So hollow section. So we are not, kita tak pakai ni, and this roll I section ni dia tinggi, dia panjang macam ni. Okay. Compared dengan H section, value ni lebih kurang macam value ini. So itu nama dia H section. So kita pakai roll H section. Jadi kita tengok part yang bawah ni saja. Whether it's up to 40 mm the thickness ataupun over 40 mm. Kita dah ada pernah keluarkan thickness 31.7 mm. So that is the thickness. T is 31.7. So kalau you tengok dekat sini up to 40 mm, 31.7 adalah up to 40 mm sebab 0 sampai 40 adalah up to 40 mm. Tapi kalau you dapat 40.001 and above, okay, dan above, dia akan jadi over 40 mm. Maksudnya lebih daripada 40 je, terus another table that you have to use. Jadi sekarang kita up to 40 mm. Jadi kita pun pakailah for XX curve B and for YY curve C. Macam soalan saya semalam. Ramai yang jawab main pakai hentam je. Whether you all start tengok video ataupun you all tengok video tak faham. I think I bagi thickness dia over 40 mm, around 41.3 ke, I lupa. 41.3 I think. And I minta you cari XX. I minta you bagi tahu XX. So bila XX curve C lah jawapan you. So here for XX curve B and for YY curve C. PCX equal to berapa. Saya tulis curve B kat situ supaya senang. Kita buat exercise dulu lah. Here we have curve B. So slenderness ratio is in our table here. Tak ada satu pun yang, tak ada number yang 58.25. Kalau tengok here this is the slenderness ratio. Okay, so yang ke bawah ni semua slenderness ratio lah. Okay, tak ada satu pun yang 58.824. So obviously you kena cari in between dia. So it is between 58 sampai 60. And then at the same time kita kena tengok juga this is dari segi dia punya row lah. But dari segi column, so mana kita nak refer tu, kita kena tengok this 265. Because our PY is 265. Kalau PY you 275, kita tengok dekat 275. 58 adalah sama dengan 217. So, bila 58.824, kita tak tahu berapa. This is what we're trying to find. When it is 60, it is 21. I suka tolak macam ni lah sebab senang kira. You boleh main. Okay, bila you tolak 58.824 sebab dia equation dia tolak dengan 58 ke atas. Automatic the other side, the right side, PCX kena minus dengan 217. Sebab dia adalah equation 214 minus 217. Kita simplifykan this thing. So here I dapat 0.824 sama dengan PCX minus 217. 60 minus 58, 2. 217 minus 214 minus 217 negative 3. What we need to do is kita darab silang. So you darab silang, you akan dapat value PCX. Negatif 3 darab 0.824, you akan dapat negatif 2.472. Equal to, so 2 times PCX, so become 2 PCX. 2 ni juga kena darab dengan negatif 217, it become, so when we simplify, so 2 PCX dekat sini. And then negative 434, you have to move at the left, so it become plus. Okay, so negative 2.47 to plus 434, it become 431.528. Okay, and then PCX, you divide by 2, you will get 215.764. Kita macam boleh agak sebenarnya. Because kalau you tengok dekat table macam ni, okay, number yang you dapat ni mesti in between this 214 dengan 217. Dia dalam range tu. So this is the compressive strength for XX. So Newton over mm square 215.76 Newton. Newton over mm square ni, you tak payah susah fikir-fikir mana pula Miss dapat unit dia sebenarnya kat sini. Okay, dia ada bagi dah dekat dalam table ni sendiri, dia ada tulis unit kat atas. And then we do the same for curve C. For curve C, YY lah. Sebenarnya for YY, kita buat untuk curve C. Slenderness ratio 103.093. The slenderness ratio is 103.093. Bila you tengok ada slenderness punya column kat sini, dekat belah kiri ni sekali kan, tak ada 103.093 pun, yang ada 102, 104 kat sini. Because dia in between this value, so kita highlight lah. And at the same time, kita tengok juga dia punya PY, which is steel strength. Steel strength is 265 PY. PY is 265. Dan kita boleh buat benda yang sama lagi. 102 is equal to 120. 103.093 equal to tak tahu berapa. 104 equal to 1. Tolak dia 103.093. minus 102 equal to PCY minus 120. 104 minus 102. 117 minus 120. Senang cerita ini tolak, ini tolak. 1.093. You do the same thing again. Cross multiply dia. You akan dapatlah berapa dia punya PCY. Oh, Fakuali.
118.361 Miss.
Okay, betul. Thank you. Thank you, Fakru Ali. So, negative 3, you darab 1.093, you will get negative 3.279 equal to 2 PCY tolak 240. So, this one you move there. So, 2 PCY equal to 236.721. PCY is 118.3605, so 361. 118.361. Compressive resistance equal to AG darab dengan BC. Okay, so area darab dengan compressive strength. Kita tengoklah berapa AG dia. AG for this section, we can have a look at the 212 area of section. Okay, so this section ni area dia 212 cm square. You kena tukar dia into millimeter square. Okay, sebab kita nak darab dengan PC kita Newton over mm square. So, kena darab dengan millimeter square lah. So, nak tukar dia millimeter square, so 212, so centimeter tukar meter darab 10. Sentimeter, maksudnya darab 10 dua kali lah sebab sentimeter square. So, millimeter square, nak tukar kena darab 10 dua kali. Okay, so dia jadi 21,200 mm square. 21,200 mm square. Here, you don't know PC. PC ada dua, nak pakai mana satu. Okay, kita akan select the value yang lower. Compare PCX dengan PCY. You will see PCY have a lower value, which is 118.361. You akan ambil 118.361 to put here. Why you pakai value yang lebih rendah? Sebab you punya kolom berdiri tegak macam ni. If the resistance to compression is higher dekat x-axis, so ini x-axis okay. Tapi YY dia tak okay. Sebab dia punya strength dia lagi rendah daripada X. Jadi kita kena consider X and YY, make sure dia selamat. So kita akan ambil strength yang lebih rendah, untuk axis yang lebih rendah, untuk kira dia punya resistance. Sebab kalau you ambil value lebih tinggi, obviously dia punya compressive resistance dia akan lebih tinggi. Okay, bila lebih tinggi, tapi how about axis yang compressive strength dia lebih rendah? Kita tak consider langsung. So dia akan fail YY tapi okay x-axis. With that will cause you punya column stay collapse lah. Sebab tak fulfill lah. So kita kena fulfill both axis. Okay, obviously kalau ini dah fulfill, okay, you pakai 1.361, dah rendah dah. Ini pun akan okay. Okay, because you consider both axes. So we take the 1.361. Taken 2509253.2. Okay, betul. Thank you. So this one is in Newton. Okay, sebab millimeter square pangkah lah. So tinggal Newton. You convert it into kilonewton. So bagi 1000, so you dapat 2500. 0.253 kilonewton. Okay, what we do is kita akan kena compare sebab kita nak tengok ini adalah compressive resistance yang can be resist, compression resistance yang can be resist by the section. However, kita kena compare dengan loading. Okay, because loading you boleh support banyak, loading you can be berapa, tapi you punya section kena boleh support berapa banyak loading daripada load tu lah. Tengok the axle load which is 1600 lah. So kita pun compare lah dengan this 2000, obviously lebih besar. Okay, which means section is suitable. Siap. Okay, thank you so much everyone. Have a nice day.